In today's video, we are going to take a look at adding and subtracting rational expressions. So we're going to look at our next operation with rational expressions. Before we do that, let's look at some very basic adding and subtracting fraction problems. We'll just look at adding ones. Rational expressions are me looking at fractions over fractions, polynomials over polynomials, just like you did with multiplication and division. However, if you think back to how do I multiply and divide fractions, that operation is a little bit more straightforward than adding and subtracting fractions. So one of the things you have to keep in mind is when I add and subtract fractions, I'm looking at simplifying when possible, and I have to get a common denominator first. So if I look at the very first problem, 1/4 plus 2/8. When I look at that, I should realize that neither of those have common denominators. So I have to get common denominators, or I need to simplify within an individual fraction. I can cancel out factors. The numerator has a 2 in it, and the denominator has a 2 in it. So it's 1/4 plus 1/4. Now, they have the exact same denominator. So now what I do is I add their numerators, and I rewrite the denominator. And then I have to simplify again. Do they both share a common factor? Yes, they both share 2. Therefore, my answer is 1/2. This differs from the next one. The next one does not have common denominators, and there's no way to simplify it out to get common denominators. So I need to multiply by that wonderful form of 1 to get those common denominators. So the denominator between 3 and 2 is going to be 6. Well, 3 times what gives me 6? Well, 3 times 2 gives me 6, which I multiply the 2 by 2 as well, so that gives me 4. This has to be that form of 1. 2 over 2 is 1. And then on the right-hand side, multiply the bottom by 3, multiply the top by 3, so therefore it's 3/6. Then I add the numerators, I rewrite my denominator, I simplify if I can. There's no common factors in the top and bottom. I'm done. Okay, last one, do that one real quick. I'm going to do it a little bit of a different way. Either way, we will get the exact same answer. What I'm going to do is I'm going to rewrite 6. 6 as factors is 2 times 3. Plus 3, I'm going to do the same thing with 4. Well, that's 2 times 2. Now, if you went through and got your common denominator, if you found your lowest common denominator, you would have found it to be 12. Because if I look within each individual denominator, this has a factor of 2 and 3. This has a factor of 2 and 2. The right-hand side is missing a factor of 3, which means the top is also missing a factor of 3. Because 2 times 2 times 3 gives me 12. Well, the left fraction is missing a 2, which means my numerator is also missing a 2. It's another way of finding that common denominator in factor relations. So now, when I simplify that together, the top is 2, the bottom is 12, plus the top is 9, the bottom is 12. Add fractions, add that numerator, attach the common denominator. Step number 3 is the way we are going to go through by looking at sums and differences of rational expressions. We are going to be looking at the factors of the denominator to see what do those denominators miss out on, which means we may have to do some work and we may have to factor them as need be. Now keep in mind we are looking at factors. In this first example, x plus 2 is the factor in that denominator. I can't factor anything out. That's the only denominator there. If I could factor more, then please make sure you factor more. So now, going back to that last example, in the denominator, I had to figure out what I was missing. So this one, I was missing a 3. So, because this here had a 3. So I had to multiply by a 3 over 3. Well, now when I go over here, this denominator here is missing a factor of x plus 2. But so is the top. Then, I had to look on the other side, and it was missing a factor of 2 because it had 2 2's. So it needed one additional 2. So that went on the top and the bottom. Over here, I look at, okay, what does this side have that the other side is missing? And that would be a factor of x plus 1. Again, it has to be a form of 1, top and bottom. So that's the process you're going to have to go through to figure out what does my denominator have to be. Because before I can add and subtract these, I have to get common denominators. So I'm going to rewrite this out as x plus 1 over its common denominator. Minus x plus 2 over its common denominator. Some of you may skip this step along the way. So now I'm subtracting. So I'm taking one fraction, I'm subtracting the other. So what I have to do now is I can rewrite my denominator, because it's common, so I just rewrite that denominator. And then I do what the numerator says. It says x plus 1 minus, I need parentheses, x plus 2. I'm subtracting the whole side. And when I subtract, realistically, you're subtracting your whole numerator. So I'm subtracting the x and I'm subtracting the 2. So this negative sign has to be sent through, which means I get x plus 1 minus x minus 2. So do what the numerator says. Simplify it. Don't forget to simplify that numerator. Go through, what can I do? X and negative x, well that's gone. 1 and negative 2, that's negative 1. Over x plus 1, x plus 2. And I'm done. Now, word of caution. This is correct. This is the process you go through. I often see happy slashing at this step. Please don't just randomly start to cross things off. The only way I can cancel is if they're factors. And you're going to see some that are going to cancel out later on. Okay, but please be really, really careful that you're not happy slashing. Just do what the numerator says. It's just basic multiplication and addition pieces with it. Okay, next example. As I stated in that last example of the basic adding and subtracting, you are going to have to look at what those factors are in the denominator, which means I have to have my denominator factored. Do I have factored denominators? No. I need to factor the x squared minus 9. Everything else is factored. Please don't happy slash. I cannot do this. Not true. There's a subtraction sign. Cannot cancel unless it's over multiplication. So I'm going to factor the left-hand side. So you got to be good at factoring at this point. Difference of two squares, x minus 3, x plus 3. So you have to see, oh, I can factor this, factor it. Now I look at what are my denominators missing? Well, if I look on this side has a factor of x minus 3 and x plus 3, whereas the right side only has a factor of x minus 3. So it is missing an x plus 3. And so is my numerator. Now I have common denominators. So I'm going to go right to the step where I say, okay, I'm going to rewrite my common denominator. Since they're common, I can just go to rewriting it. And I'm going to do what the numerator says. It says 3x plus negative 3 times x plus 3. Since it's a plus, a little bit more straightforward across the top. So I'll do some order of operations. So I do my multiplication first. So that's 3x minus 3x minus 9 over x minus 3, x plus 3. So I simplify that top, 3x minus 3x, well that's 0, minus 9 over x minus 3x plus 3. Do not feel the need to expand out that denominator. Leave it in factored form, perfectly acceptable. Okay, so these are kind of the basic types of problems that you're going to be looking at. How do I get that common denominator? Do my numerator and then simplify. We haven't had to simplify yet. Okay, here's the next one. This kind of encompasses most of what you're going to be doing. So, to begin with, look, do I have common denominators? No. Let's make them common. Before I can do that, I have to factor the denominators. Because if I don't factor them, I may multiply by more than what I need. You may wish to also factor your numerator. The next problem, I'll show you why it might be helpful to factor the numerator. But I'll tell you, in this case, it's not helpful. So we'll leave it as is. In the next one, I'll show you what cases would be helpful. So I've got to factor my denominators. So I have a trinomial here, product and sum. So I end up getting x plus 3 and x minus 2. Its numerator is 2x plus 16. Minus this numerator is x plus 11, and I factor that trinomial, and I get x plus 3 and x minus 1. So now I look at my denominators. What factors are my denominators missing? The left part is missing an x minus 1. The right part is missing an x minus 2. So I rewrite that common denominator. Doesn't matter which order you do it in. And I rewrite what the numerator says. It's kind of long. Okay. What I'm going to do is I am going to pull the numerator out of this for now. I'm going to ignore my denominator, but I'm going to attach it each time along the way. So I'm just focusing on the numerator, knowing all along I've got that ugly denominator underneath there. So I have to simplify this expression. This is just basic order of operations. Okay, so I've got multiplication here, subtraction sign, and then multiplication here. So I know I have to do multiplication before I can do addition and subtraction. So I'm going to start by multiplying them out. Expanding. First, outside, inside, last. So on the first one, I get 2x squared plus 16x minus 2x minus 16. And then I'm subtracting. This is important. You got to have a parenthesis there. I'm subtracting that whole product. So expanding that out, I get x squared and then minus 2x plus 11x minus 22. So now I'm going to do some simplification. Slide this down. Ooh. So combining my like terms here, I get 2x squared plus 14x minus 16. Subtracting this entire quantity, x squared plus 9x minus 22. And then since I'm subtracting all of this, that subtraction goes through to everything. So after that goes through to everything, and I combine my like terms, so it's a 2x squared minus x squared is x squared. And then x's, I have 5 x's, and then constants, I have 6 of those. Now, all of these had denominators. So this is what we've done all along, and I just put my denominator, my common denominator, in the bottom all the way across the board. So this is kind of the process we went through. Part of the reason, again, I don't do my denominator with it is sometimes it starts to get confusing in terms of keeping track of things. Because really, all we're doing, once we have a common denominator, I just have to simplify that numerator. And that numerator is sometimes the harder part of it. So if you kind of ignore that denominator initially, that's fine. You just have to remember to bring it back. Otherwise, your problem is going to be completely off. So let's continue working with it. So now I've got everything put together. I've simplified my whole numerator. The last step in any adding and subtracting problem is I have to simplify if possible. In order to simplify, I'm going to have to factor my numerator. So when I factor that numerator, I get x plus 2 over x plus 3. And then that's, of course, over that common denominator. Now, since everything's factors, if I have exact factors, top and bottom, I can cancel. X plus 3's. That's it. That's x plus 2 over x minus 1. X minus 2. And that is adding rational expressions. That encompasses most of the processes you're going to have to do. You may have to do a little bit more with the simplification. Maybe you'll have to factor out a -1. But this problem right here is pretty much the tip of what you guys are going to be doing. Now, here's one last problem. I'm not doing the whole thing, but I want to show you why it might be helpful to look at factoring everything, because some things might cancel before you get started. So if I look at this problem on the left-hand side, it's x minus 2, and then my denominator is x minus 2, and then x plus 3. And then, of course, I have this x plus 1 over x minus 6. Now, right away, within that fraction, I can cancel. Because it's all factors within that problem. And that gives me 1 over x plus 3 plus x plus 1 over x minus 6. Now when I keep going, I can get my common denominator. This is missing an x minus 6. This side is missing an x plus 3. I've got common denominators. I go from there. If I wouldn't have done this, canceling it, then what would have happened is in the first problem, I would have had to multiply this side by an x minus 2x plus 3, x minus 2, x plus 3, and then this would get an x minus 6. And this right here, when I multiply it together, right here, would be a cubic. And then I have to add that with a quadratic. And then I have to factor a cubic, and you have to do the factor theorem. So if I cancel right away from the very beginning, then I only have a quadratic in the top, and I can factor a quadratic. So if you can cancel ahead of time, please do so. But you cannot cancel unless it's all factors. It's all attached by multiplication, and then, of course, your division sign.